Space is big, it's also incredibly cold. But some places are colder than others. The Boomerang Nebula holds a special record. It's the coldest known natural place in the entire universe. Imagine a place colder than the vast emptiness of space itself. That's the Boomerang Nebula. This fascinating object is a reminder of the incredible forces at play in our universe. In its depths, we see not just extreme cold, but also clues about the life cycle of stars and the nature of matter. This essay will take you on a journey to the Boomerang Nebula. We'll explore what makes it so cold, how it got its shape, and why it matters to scientists studying the cosmos. Get ready to explore the universe's ultimate freezer. So, where is this cosmic refrigerator located? The Boomerang Nebula resides roughly 5,000 light-years away from Earth. That's a distance so vast it's hard to even fathom. To find it, you'd need a telescope and a star chart pointed towards the constellation Centaurus. Don't let its name fool you. The Boomerang Nebula is not a permanent fixture. It's a protoplanetary nebula, a stage in a star's life as it transitions towards becoming a planetary nebula. This means the Boomerang is a dynamic, evolving object constantly changing over cosmic timescales. Here's the mind-blowing part. The Boomerang Nebula is colder than the space surrounding it. Empty space has a temperature, a leftover glow from the Big Bang called the cosmic microwave background radiation. It measures a frigid -455 degrees Fahrenheit, or -270 degrees Celsius. Amazingly, the Boomerang Nebula is even colder, clocking in at a mere 1 degree Kelvin. That's -458 degrees Fahrenheit, or -272 degrees Celsius, just a smidgen above absolute zero, the theoretical point where all molecular motion stops. This extreme cold makes the Boomerang Nebula a unique laboratory for scientists to study the behavior of matter at incredibly low temperatures. It pushes the boundaries of our understanding of physics and thermodynamics. What created this cosmic freezer? The answer lies in the heart of the Boomerang Nebula, where a dying star is putting on a final, spectacular show. This star, once similar to our own sun, is nearing the end of its life. As it runs out of fuel, it sheds its outer layers into space at incredible speeds. This ejected material, a mixture of gas and dust, expands outwards, creating the beautiful and ethereal shapes we associate with nebulae. The Boomerang Nebula's central star is losing mass at an astonishing rate, about 1,000th of the sun's mass every year. This rapid expulsion of material is a key factor in the nebula's extreme temperature. The Boomerang's shape. Why it looks like that. The Boomerang Nebula isn't just incredibly cold, it also has a distinctive shape. This nebula, located about 5,000 light-years away in the constellation Centaurus, is a fascinating object of study for astronomers. Its unique structure has intrigued scientists since its discovery. As its name suggests, it resembles a boomerang, or perhaps a bow tie, with two distinct lobes of material extending outward from a central region. These lobes are not just for show. They tell a story about the processes happening within the nebula. This shape arises from the way the central star is expelling gas. The star at the heart of the Boomerang Nebula is in a late stage of its life, shedding its outer layers in a dramatic fashion. The gas isn't being ejected evenly in all directions. Instead, the expulsion is highly directional, creating the distinctive lobes we observe. Instead, it's being channeled out from the star's poles at incredibly high speeds, up to 360,000 miles per hour. This rapid ejection of gas is a key factor in shaping the nebula. As this fast-moving gas slams into the surrounding interstellar medium, it creates shock waves that heat up the gas and cause it to glow. These shock waves are not just a visual spectacle, they also provide valuable information about the conditions within the nebula. The shape and orientation of these outflows determine the overall shape of the nebula. By studying these outflows, astronomers can learn more about the life cycle of stars and the processes that govern the evolution of nebulae. The Boomerang Nebula, with its striking appearance and extreme conditions, continues to be a subject of intense study and fascination in the field of astronomy. Hubble's View and Beyond. Seeing the Invisible. Much of what we know about the Boomerang Nebula comes from powerful telescopes like the Hubble Space Telescope. This iconic instrument has been orbiting Earth since 1990, providing us with a window into the farthest reaches of the universe. Its advanced optics and high-resolution cameras have allowed scientists to capture breathtaking images and gather invaluable data about celestial objects. Hubble's sharp vision has given us stunning images of the nebula, revealing its intricate structure and allowing us to study its composition in detail. The Boomerang Nebula, with its unique hourglass shape, has been a subject of fascination. Hubble's observations have shown us the nebula's complex layers of gas and dust, shedding light on the processes that govern its formation and evolution. But Hubble isn't the only tool astronomers use to study the boomerang. Ground-based observatories and other space telescopes complement Hubble's findings, each bringing their own strengths to the table. These instruments work together to provide a more complete picture of the nebula and its characteristics. Because the nebula is so cold, it emits very little visible light. This makes it challenging to observe using traditional optical telescopes. The Boomerang Nebula is considered the coldest known object in the universe, with temperatures dipping just a degree above absolute zero. To truly understand it, astronomers also rely on telescopes that can detect other forms of radiation, such as infrared and radio waves. Infrared telescopes can see through the dust and gas that obscure visible light, revealing hidden features of the nebula. Radio telescopes, on the other hand, can detect the faint signals emitted by the coldest regions of space. One such telescope is the Atacama Large Millimeter Submillimeter Array, or ALMA, located in Chile. ALMA is a state-of-the-art observatory that consists of 66 high-precision antennas. These antennas work together to observe the universe in millimeter and submillimeter wavelengths, which are ideal for studying cold objects like the Boomerang Nebula. ALMA is particularly adept at detecting the faint radio waves emitted by cold dust and gas. Its observations have provided new insights into the physical conditions within the Boomerang Nebula, helping astronomers to map its structure and understand the processes at play. Observations from ALMA have been crucial in mapping the boomerang's structure and confirming its ultra-low temperature. By combining data from Hubble, ALMA, and other telescopes, scientists are piecing together the story of this enigmatic nebula, revealing the secrets of its past and the mysteries of its future. Adiabatic expansion, the science of cold. Now, let's delve into the physics behind the Boomerang Nebula's extreme cold. The primary mechanism at play is something called adiabatic expansion. Imagine a can of compressed air. When you spray the can, the air inside expands rapidly. This expansion causes the air to cool down. That's adiabatic expansion in action. The same principle applies to the Boomerang Nebula. The gas expelled by the central star is expanding rapidly into the vacuum of space. As it expands, it does work against its surroundings, and this work causes the gas to lose energy and cool down dramatically. A temporary chill. The future of the boomerang. The Boomerang Nebula's reign as the universe's ultimate freezer won't last forever. As the central star continues to evolve, its energy output will change, and the nebula's temperature will gradually rise. Eventually, the central star will become a white dwarf, a small, dense, and incredibly hot stellar remnant. The intense radiation from the white dwarf will ionize the surrounding gas, causing it to glow brightly. At this point, the Boomerang Nebula will have completed its transformation into a planetary nebula, a glowing shell of gas surrounding a dead star. While no longer the coldest place in the universe, it will still be a breathtaking sight, a testament to the beauty and power of stellar evolution. The bigger picture, why it matters. The Boomerang Nebula might seem like a distant and esoteric object, but its study has profound implications for our understanding of the universe. This nebula, located about 5,000 light-years away in the constellation Centaurus, is not just another celestial body. It is a cosmic enigma that holds secrets about the very fabric of space and time. By studying objects like the Boomerang Nebula, we gain insights into the life cycles of stars from their birth in stellar nurseries to their eventual demise. These processes are not just theoretical, they are the very mechanisms that have shaped our own solar system and by extension life on Earth. The processes that shape galaxies are incredibly complex, involving gravitational forces, dark matter, and interstellar gas. The Boomerang Nebula, with its unique properties, offers a window into these processes, helping us understand how galaxies evolve over billions of years. And then, there are the fundamental laws of physics that govern our universe. The Boomerang Nebula challenges our understanding of these laws, particularly in the realm of thermodynamics. Its extreme cold, measured at just 1 degree Kelvin above absolute zero, is a natural laboratory for studying matter under conditions that are impossible to replicate on Earth. The Boomerang's extreme temperature in particular provides a unique laboratory for studying matter under extreme conditions. This helps scientists test the limits of physical theories and explore new realms of possibility. It challenges our understanding of thermodynamics and provides clues about the behavior of matter at the coldest temperatures imaginable. These insights could have practical applications, from improving cryogenics to developing new materials with extraordinary properties. The Boomerang Nebula is not just a distant curiosity, it is a key to unlocking the mysteries of the universe. Its study helps us understand the fundamental forces that shape everything from the smallest particles to the largest galaxies. So, the next time you look up at the night sky, remember the Boomerang Nebula, a cosmic refrigerator reminding us of the vastness, beauty, and wonder of our universe. It is a testament to the incredible forces at play within it, and a reminder of how much we still have to learn. This nebula is a symbol of the endless quest for knowledge that drives humanity to explore the cosmos. It stands as a beacon of curiosity and discovery, urging us to look beyond our world and into the infinite possibilities that lie beyond, and the incredible forces at play within it. The Boomerang Nebula is a reminder that the universe is full of wonders waiting to be discovered, each one offering a new piece of the puzzle that is our existence.